Hello, I'm Aubrey here and welcome to Module 4. In this module, we will be discussing the different types of rocks. Now, in the previous module, we have already given a definition of rocks and minerals. But just to recap the difference between the two, minerals are specific materials, so they are only made up of one homogeneous solid with a specific chemical composition, while for rocks, they're more of aggregates. So they are a combination of different types of minerals. They form in different ways, which may lead to forming with organic substances or materials inculcated in them. Okay, so that's the difference. Now, for the learning objective, students should be able to classify rocks into igneous, sedimentary, and metamorphic, which I know is very basic for you guys since we have been discussing this since elementary days. But in this discussion, we will be including additional information. So some insights on how each of these rock types form. We will be discussing subtypes as well. And we will also be giving you examples of different locations around the world which have amazing collections or examples of these types of rocks. Okay, so just a quick rundown of the three main types of rocks. We have igneous, sedimentary, and metamorphic. And the meaning behind each name already give away the formation or how they are formed. So for example, igneous rocks, it came from the Latin word ignis, which means ignite. So obviously this has been formed from fire, either through magma inside the earth or lava, which is on the earth's surface. Next, we have your sedimentary rocks, which were formed from sediments, thus sedimentary. And then you have your metamorphic rock, which is, if you know the term morph, it means change. So metamorphic rocks must come from pre-existing rocks. So it could either be igneous, sedimentary, or another type of metamorphic rocks. And due to environmental factors, it changed to a different type of rock through metamorphose. Great. Now, for people who plays Minecraft, gamers out there, you are familiar with this type of rock. Now, the interesting thing about Minecraft is it features different types of rocks, one of which is obsidian, which you can only find if you are near lava underneath the earth. So based on the definition that we have given of the three different types of rocks, what type of rock is obsidian? Okay, so yes, obsidian is an igneous rock. So in the game, magma, technically that's magma, cools down and then turns into your obsidian rock. And in the game, you can only break obsidian rock, which has a moss with a diamond. So diamond has a moss hardness scale of 10 and obsidian has 8 or 9. So it was actually a bit accurate when it comes to cutting up your obsidian rocks. Okay, so much for Minecraft. So the first type of rocks that we will be talking about is igneous rocks. And there are different types of igneous rocks, as you can see in this image. The textures, the materials, and also the way they have formed creates different types of igneous rocks. Okay, so we can classify igneous rocks based on their formation. So there are two ways on how igneous rocks can form, either inside the Earth's surface or inside the Earth or outside. So those who were formed inside Earth is called intrusive igneous rock. So just remember, inside the Earth, that's intrusive. So intrusive igneous rock formed when magma cools down deep inside the earth. Okay, then it usually, since it's deep inside the earth, the temperature is pretty constant and pressure is high. Thus, the resulting rocks has been cooled slowly. Then the main characteristic of, let me just get my pen. of igneous rocks which are intrusive is coarse-grained rocks, meaning the components that you see or the materials within the rocks itself is visible, that they have big visible materials within inside the rock. Now, there are, of course, some exemptions. So, for example, obsidian, which I showed you during our mineraloid discussion, obsidian has been cooled rather fast in comparison to the other types of intrusive igneous rocks. So, imagine magma suddenly being pushed up towards the surface, but it did not break the surface. So, it is still relatively fast cooling, but not like the other type of rocks, thus which leads to this glassy formation. Rhyolite is another type of igneous rock. Usually when it comes to the rhyolite, they are from magma, which is very thick. That's why you don't see any bubbles inside. And then you have your scoria, which is from magma, which usually have a lot of gas bubbles. So if you can imagine, this type of magma flows very quickly and it allows the formation of gas bubbles. Okay, so next type of igneous rock is your extrusive igneous rocks, and these extrusive igneous rocks forms on the Earth's surface. So here, let's put that out, Earth's surface. Okay, so due to the rapid cooling, it has very specific properties. It doesn't allow the formation of minerals, crystals rather. So in the first type, the intrusive igneous rocks, glassy formations is possible. Also the formation of small crystals, thus creating a coarse-grained formation. So that's another reason why it's coarse, because you can see that there are some crystals formed within the rock itself. But for extrusive igneous rocks, you can't form this crystals because of the fast cooling. So in comparison, they have fine grained rocks. Okay, they can maybe be vesicular. So vesicular is a term which our geologists use to describe rocks with air pockets in them. So for example, this pumice here on the top left, you can see that there are holes in the rock itself. So that's meaning that's vesicular. It contains air bubbles. The scoria here also contain gas bubbles. So it's also vesicular. But vesicular types of rocks are most common in extrusive igneous, because since they cool down in the surface itself. So being fine-grained, a good example is basalt. You can't see the particles that make up basalt if you look closer. Okay, so again, intrusive igneous, inside the earth, slow cooling, formation of crystals, coarse-grained. Then for extrusive, it cools on the Earth's surface, rapid cooling, no crystals, fine-grained, and usually contains air bubbles. Okay, so just to differentiate the formation of the two, again, extrusive igneous rocks form either from volcanic eruptions or other similar volcanic activity. So magma now reaching the surface turns into lava, and once that cools down, then that creates your extrusive igneous rocks. So not necessarily in big eruptions, it could be just slow lava just spewing into the surface. There, so this creates fine-grained and no crystal growth. Then for intrusive igneous, since they are deep into the earth, they can form slowly, thus leading to the formation of crystals and other coarse-grained materials. Okay, so in this image, it's showing us the different ways on how intrusive igneous rocks are formed. Because if you're going to go through this deeply as a geologist, there are actually different types of intrusive igneous rocks formation depending on how they form. So for example, all of this, the general term for all of this is pluton. That's why intrusive igneous rocks is also called plutons. while extrusive igneous rocks are also called volcanic rocks. Okay, so you have your batholiths. So batholiths are large magma structures that has been cooled down eventually. So if you can imagine underground magma chambers, due to the lack of continuous heat, they eventually cool down after several years. You also have your dikes. So these are magma that is forming upwards towards the surface. The seal are magma also pushing to the surface, but instead of going upwards, it moved horizontal. Okay, then you also have your volcanic neck. So you can imagine a volcanic neck. It's like the volcanic chamber. So the crater itself is full of magma. Not necessarily it will always erupt, but sometimes it cools down in this formation called a volcanic neck. So how does it look like in the real world? This is a batholith found in Sierra Nevada. So look at this large structure. For me, this is super amazing because if you can imagine this large thing used to be underground. So this thing was once magma, and after hundreds, maybe thousands of years, it cooled down. And then on the side, since this used to be land before, there used to be sediments under this. But due to weathering process, it later revealed the more solid igneous rocks underneath, thus revealing the batholith of Sierra Nevada. So that's super amazing for me. Just an example of how different our Earth was way back then and how much change could happen in several hundreds of years. Okay, so this is also another example. This formation here, the dikes are igneous. Then the surroundings here are all sedimentary. That's why the magma could cut through the layers. Then since they are sedimentary, they are more prone to weathering. So eventually the igneous rocks has been exposed. So this is a picture from the Capitol Reef National Park, Utah. Okay, so this is another example of an igneous rock formation, but instead of being a dike, because a dike is upwards, it's called a seal because it's horizontal or lateral to the layers here. So you have rock layers here, and then you have this dark formation. That's a seal. Okay, another cool example is a volcanic neck that has eventually been exposed. So imagine all of this location used to have a volcano, and then after hundreds of years the volcano eroded, but the igneous rock or the magma neck or the crater inside the volcano cooled down and created this formation called the Devil's Tower in Wyoming, United States. Okay, so those are just some of the examples of the amazing igneous rock formations in our planet. Okay, so again, on the other hand, extrusive igneous rocks forms on the surface. So they are more common than basalt, which is a type of extrusive igneous rock, is quite common. It's the most common igneous rock there is because, again, as long as there is magma or lava spewing into the surface, you form your extrusive igneous rock. Okay, so we are giving some image examples of our igneous rocks. In here, it is showing you the different technical terms that geologists use in referring to the textures of the rock samples. So for example, here, pegmatite, you will see that it's made up of different types of minerals, and it also creates these crystals. When we say coarse-grained, the minerals, usually this is intrusive, as we have mentioned, and there are also crystal formations since they have been formed slowly. When we say medium-grained, it's quite tricky because when you say medium grain, they could be in the process of already cooling down before they were forced into the surface. That's why it creates this medium grain texture. Then you have your fine grained, which is a characteristic of extrusive igneous rocks. Okay, so we have this glassy feature, your obsidian. Okay, a feature of intrusive igneous rocks. You have porphyritic. So porphyritic is similar to my explanation before, because as you can see, it's made up of different types of grains. You have this large coarse grained materials, and then you have this fine grain. So what happened here? In the earth, these coarse grained materials has already started to cool down, and then it later spewed into the surface and created another type of cooling down or faster cooling down. So you have a combination of both types of grains. So that's called porphyritic. Okay, then you have your vesicular because it contains air bubbles, common in basalt types of rocks since they cool in the surface. And then you have your welded type of rocks, which has these bands formation due to difference in minerals. Okay, so when it comes to the rocks itself, there are different ways on how to classify them. It's either you classify them based on their texture, and another is their mineral composition. Okay, so for the mineral composition, this table is actually showing you what are the composition of the igneous rocks. So when it's dark colored and high in density, it most likely has magnesium and iron inside them. So gabbro and basalt are dark colored in igneous rocks, and they contain these types of minerals. While for the light colored ones and low in density, they contain either the orthoclase feldspar or quartz. Okay, so this is the way you classify rocks based on their composition. So the intrusive and extrusive and extrusive igneous types of rocks are based on their formation. Now, this is based on their composition or the minerals which are inside them. Here, categories by mineral composition. So first, felsic, they are lightly colored materials because they mostly contain silica and quartz. So it's referred here light colored and low density. So if it's mainly quartz and silica, that's felsic. Now, if it's mafic, that means there is a high percentage in that specific type of rock of iron and magnesium, thus creating the ferromagnesians. Now, if there is a higher concentration of iron and magnesium, then that's considered as ultramafic. But if it's 50-50, then it's considered as intermediate. So a combination of light and dark colored minerals. Okay, so some example of felsic. So obviously they are very light colored because of the silica and quartz within them. Okay, so the granite is intrusive, and as you can see the texture, it has larger particles within it. In comparison, rhyolite have fine crystalline texture to glassy formation. Okay, diorite is an example of intermediate rocks, so a 50-50 combination. So here you will see that there are darker minerals within it, and then there's a combination of light colored materials. Okay, and then also andesite, it's the same as well. You have your light colored materials here, and then you have your dark materials surrounding it. Okay, gabbro is a type of mafic rock as well as your basalt. So very dark in color. This one is extrusive. This one is intrusive. Ultramafic peridotite. So you have here crystalline formation, and then you have your lava here, cooled down lava, which is an extrusive type. Before we end our discussion in Igneous Rocks, something that is worth discussing is the Bowen reaction series. So Norman L. Bowen has been praised due to his contribution to petrology, or the study of rocks. So he studied extensively how certain minerals are responsible, or how certain minerals behave in the cooling down magma. So in this picture right here, it is showing you a summary of the Bowen's reaction series. So just to break down the parts of this picture or this image so that you will be able to understand the contents of this diagram. So first you have your the image or the scale of temperature. So if it's higher up, that means high temperature, and then lower temperature here at the bottom. Okay, so you can surmise that olivine is exposed to higher temperature. Then even at the high temperature, the first minerals that will form, okay, will be olivine. So the first minerals that will crystallize will be olivine at high temperatures. Then the last one would be quartz, because they've crystallized in low temperatures. Okay, so that's how to use this part of the graph, or the diagram. Then on this part, you should see the composition of the rock types. So for example, ultramafic, then most likely it contains either olivine or calcium-rich feldspar. Okay, then if it's mafic, then it contains some calcium-rich feldspar or pyroxene. If it's intermediate, it's either biotite mica or sodium-rich feldspar. And if it's felsic, you have your light-colored minerals here, your potassium feldspar, quartz, and muscovite mica. So that's how you understand the relationship of the minerals here that is shown to the categorization of intrusive and extrusive igneous rocks. Okay, so what is the middle part saying though? You have here your discontinuous series of crystallization and your continuous series of crystallization. So let's go to the right side because that's easier. Okay, so according to the Bowen's reaction series, the first remember that when it comes to magma, they are made up of molten minerals and rocks. So when it comes to the cooling down process, since the minerals are made up of different types of elements, basically, and the elements have different reactions to different levels of temperature. So calcium-rich feldspar are actually the first to form even in high temperature. So that's the first thing that you will see in a cooling down magma. But eventually, more as the magma cools down further, you will see the formation of sodium-rich feldspar further on. And then as the temperature moves lower, you will see the formation of potassium feldspar and quartz. So these are always the last to form. Okay, how about on the left side? So this is more tricky. So the first part, you have your olivine. So the olivine is the first mineral that will show up even in the high temperatures. And then later on, since olivine is already formed, but the surrounding magma is still quite high, if the environment will allow the continuous cooling down of the magma, it will turn into pyroxene. So after further cooling down, it will now rearrange itself and become your amphibole. And then later on, the amphibole will turn into your biotite mica. Okay, so this continuous series of crystallization. But ultimately, these are the last to form and would be the more common of all in the series. Okay, so this just shows you the groups of the different types of igneous rocks based on their composition, some examples of rocks within them, and then the minerals which form these types of rock. Okay, so that should actually take care of our igneous rock discussion.